everyone, and welcome to our first Big Data webinar for March. My name is Jan-Willem Middelburg, and I'm going to be your host for this webinar today. And we have selected a very interesting topic for today, which is to talk about big data business objectives. In the course of this webinar, I'm going to show you why big data business objectives matter, and more importantly, how they will lead towards the selections of model building and algorithms to solve common business problems. Before we get started with the session today, let me make you familiar with some of the logistics of these sessions. Note that all participants have been placed in listen-only mode, so you can only be unmuted if you ask yourself to be unmuted. We kindly encourage you to ask questions and put all of your comments through the question box that you will see on the left-hand side of your screen. Towards the end of the session today, I will moderate all of the questions that come in, and please feel free to also ask questions around how do you apply some of the things I will show in your own organization. Note that the session today is being recorded and that the recording will be made available to all webinar participants that are joining us today. The recording itself will be made available around 1 or 2 days after the end of this session. Good, let's go have a look at what are we going to talk about in today's session. I've subdivided today's session into 3 main topics. First of all, I'm going to explain to you why the definition of business objectives is very important to solve data problems and why this fits within the larger context of the enterprise big data framework. After that, we'll dive into detail. So you might or might not already know that there's 6 different common business objectives that data science and big data problems are trying to resolve. So in this session, we're going to dive deeper into that and understand the crucial differences between that. Towards the end of the session, I will wrap up this particular topic and showcase you why this is relevant in a big data and data science environment, which kind of algorithms match which particular business questions, and how you can guide yourself in your organization to select the right kind of algorithms in order to resolve that. So we have a full program today, so I suggest that we're just going to get started. This webinar is made available to you by the Enterprise Big Data Framework Alliance, which hosts a lot of these free sessions, free content, and provides a wealth of knowledge when it comes towards content around data best practices. The mission of the Enterprise Big Data Framework Alliance is to inspire, to promote, and to develop excellence in big data best practices across the globe. I'm always very honored that we have a truly global audience with people joining everywhere between Australia and the US, and today is going to be no different. What makes the Big Data Framework Alliance unique is that it takes a vendor-independent approach towards enterprise big data. So we're not going to dive into specific technologies, but we'll look specifically at which kind of capabilities are necessary to grow data science capabilities within the enterprise. On the right-hand side, you see some of the materials that this webinar is based upon. So after this course, if you want to learn more around business objectives, algorithms, data analysis, I'm strongly going to encourage you to download the Enterprise Big Data Analyst book. Good. Let's get started at giving you a little bit of perspective of the scope for today. What is it exactly that we're going to be talking about? And in order to start understanding why business objectives are so crucial towards data science problems, you need to be able to put that into the bigger picture of the data analysis process. A graphical representation of the data analysis process is listed on the screen in front of you. And you can see that it consists of 5 main stages. We're moving in data analysis questions always from the left towards the right. So starting with a business objective, moving towards ingestion, preparation, and analysis, and finally to present the results of our data analysis. Within this process, there are a lot of subtopics and quite complicated steps that we would need to take in order to solve a particular question. So in the webinar for today, we needed to have a little bit of a scope because I can easily talk about this for a couple of days. So what we're going to focus on today is the left-hand side of the data analysis process, which is the business objectives. We've decided to start with this particular topic because we are planning to have a sequence of other webinars, and during each webinar, I will present one of these 5 different topics. But we're going to start at the very beginning, and that is at the objective stage. Because every data analysis or every big data science problem starts from a particular question. Businesses use data analysis, data science in order to get specific results that they're aiming for. So before we start diving into any actual analysis itself, it's important to understand the question. Asking the right kind of question is of paramount importance to ultimately creating a successful data analysis. And in the course today, I'm going to give you a bit more of an overview of what are the different types of objectives that exist and how do they relate towards the rest of the data analysis process. On the slide in front of you, you can already see that there are 6 different business objectives that we're going to be looking at in more detail. You see descriptive, exploratory, inferential, predictive, causal, and mechanistic types of business objectives. And in the session today, I'm going to be diving a little bit deeper into that and try to give you the bigger picture around which types of analysis solves each particular business question. But I always think it's good to start with the bigger picture in mind because it gives you this overview of where to place things exactly. Good. As I mentioned, we're going to be looking at 6 different types of business objectives because these business objectives are primarily used within organizations. Technically speaking, there are also a number of other objectives that you could solve with data and big data, but they belong more towards the research domain. The reason that I've selected these 6 business objectives is because they have the word business in it. They are questions, problems, and challenges that you might encounter in any professional organization. And with professional organization, I mean a corporate environment that could also be non-profit or government related. In order to kind of give you a bit of a mind map of how we're going to traverse all of the different business objectives, you can have a look at the flow chart that you see in front of you. By asking yourself a couple of quick questions, you can very easily see and analyze which types of business objective you're actually looking at. So we're going to start at the top left and see the first key question. If you need to report without any interpretation, then it's very likely that we're going to see a descriptive business objective. If you're searching for something unknown or have objectives like data mining, then the business objective that you're typically looking at is an exploratory business objective. Those are the 2 simplest and most easy forms of data analysis, and I will cover those within the next few minutes. If your analysis requires a little bit more of a deeper understanding, it is very typical that you would need to research relationships between different variables. And if that is the case, there are 2 main substreams. First of all, many organizations are very interested to know if they can make predictions based on patterns in data. If that's the case, we say that we are looking for how variables influence each other. Within this domain, we can look for a number of different patterns. If we are looking for a causal relationship that explains why one variable is changing because of another, we are either within causal or mechanistic business objectives. If we're trying to predict individual measurements, which typically happen on univariate data, then we are more in the domain of predictive and inferential business objectives, so that we can prove a specific hypothesis or can make a prediction around an unknown data set. Let's dive into that a little bit more in detail and explore the differences between all of those. We're going to get started with the most easy form of a business objective. and that is to just simply describe something. Making a description of the data that you have in front of you is the foundation or cornerstone of business intelligence, data analysis, and very rudimentary forms of analyzing data in spreadsheets. Descriptive business objectives don't seek to make extrapolations, but they typically consolidate information that is available within the organization or in third-party data systems. What we are aiming for in descriptive business objectives is to summarize. And especially if you have significantly large data sets, this summarization is a little bit more complicated than you might originally see. Many of you will be familiar with making descriptive analysis in spreadsheets or Excel with very standardized kinds of data formats. But in larger organizations and in big data environments, you typically need to summarize data across hundreds of thousands or even millions of different observations. In order to do that, we need to know exactly how to run specific algorithms across those data sets. So a descriptive business objective is trying to solve a business problem, which is relatively easy to solve, but is going to ask you to summarize and consolidate data. I've listed a number of critical examples that you will see here on the slide. So key questions that you can think about is, what is core characteristics of a customer data set, maybe across all of the different stores in different parts of the world. You also see that we are using descriptive business objectives most frequently for reporting. So reports like how many people visited our website, what are people saying around us online, or how do customers rate our particular services, are all examples of descriptive business objectives. As the term indicates, it's really to get a description from a particular data set. And then already, in order to do this, you would need to master some very critical data analysis skills, because typically the answer or the summary data is hidden within the data set itself. Let's look at how this relates to different kinds of data analysis techniques, and most particularly algorithms. In order to understand how you can solve a descriptive business problem, you need to know a little bit around descriptive data analysis techniques. And the first question that you always need to ask yourself is whether you need to make a description around a single data characteristic, which we call univariate analysis, or whether you're challenged to make a description across multiple variables. For each of those, there are different kinds of statistical techniques with which you can retrieve the answer. For univariate analysis, finding the answer is relatively straightforward and simple, because you can use the algorithms from the descriptive analysis domain, as well as the measures of dispersion or variation. So in many cases, we would be interested to know around how much inventory we sold, how much inventory we have on stock. There we can use means, median, modes, or for instance, particular ranges of data points. If you're using univariate analysis, it's very common to use visualizations like histograms, stem and leaf plots, or even bar charts and line graphs, because they give you particular trends over time. In case you need to describe and make descriptions around multiple variables, it already becomes slightly more complicated. And in this domain, we're typically looking at correlations, covariances, and standardization. So the first main objective to always take in the back of your mind is, what is the challenge that we're trying to solve? And if we are in need of making a description around a data set, are we looking at a uniform data set with just one particular variable? Or are we actually looking at describing across multiple different characteristics and different columns? So that's our first form of business objectives. I've started with this because this is typically the most easy form of data analysis and uses the most easy techniques to get started. Let's dive a little bit more in detail and go one step deeper. And in going one step deeper, we're going to be looking at exploratory business objectives. What makes exploratory business objectives very interesting and very relevant is that with exploratory business objectives, we don't always know upfront exactly what is it that we're looking for. So in exploratory business objectives, we're trying to analyze specific data sets to make purposeful discoveries. And we can do this by looking at trends, correlations, or specific variables between different data. Because we are literally exploring a data set, one of our main objectives is always to shift through data and see if we can find something interesting. And for that reason, this exploratory business objective is also better known as data mining. You could also say it another way: data mining algorithms typically are used to find an answer towards an exploratory business objective. In order to come towards an answer right here, I've listed again a number of sample problems, which are very relevant for most organizations today. Questions like which products are likely sold together, or which ones should be packaged together or offered together when people check out, can significantly increase the value of cards and businesses. Also, in particular larger data sets, we might be looking for specific patterns that will indicate that something might happen in the future. So for instance, whether any specific variables are correlated with fraud, or whether we could already start seeing that a fraudulent transaction is up and coming. We also see that exploratory business objectives are very much used within the domain of marketing, looking at which marketing campaigns are most effective, or for instance, which customers are likely to leave us in the future. With exploratory business objectives, the whole purpose is to make sure that we find out what information is hidden within our data set. And in order to understand that, we need a number of exploratory data analysis techniques. And it's basically not possible to mention anything around exploratory data analysis techniques without mentioning the book of John W. Tukey, who is considered one of the godfathers of data analysis. Exploratory business objectives are best resolved with these particular techniques. And in order to solve that, it's generally subdivided into two main categories. First of all, you would like to use quantitative techniques, which will shift through the data typically automatically and can start to identify patterns between different data points. The most common algorithms and operations that we're using within quantitative exploratory data analysis are techniques like correlation, outlier detection, and especially time series analysis to see how things change over time. By looking and shifting through massive quantities of data, we can start to identify patterns that might have a particular business value. Generally speaking, the more data your organization has and the better it is collected, the more value is potentially hidden within those data sets. And that's why exploratory data analysis techniques can be very valuable. Many organizations have done exercises where they look at which products are best going together, or for instance, which particular design aspects do people like. And that directly results into increased sales, better customer satisfaction, and therefore has a direct impact on business results. Because most people who don't have a data analysis background find these quantitative techniques difficult to interpret and understand, it's also very common to include some of these analyses within more visualizations. And prime visualizations that are applicable for exploratory data analysis are things like box plots, histograms, as well as scatter plots, because they can very easily make data analysis available and viewable for many people at the same time. Good, so after descriptive and exploratory data analysis, which I think most of you will be familiar, it's time to go into some more complicated forms. And the next element that we're going to be looking at is an inferential business objective. And this business objective is really used to make inferences as well as predictions around a larger data set that you are interested in. Let's have a quick look at how that works exactly. Let's start with the definition of what we mean with inference. An inferential business objective is going one step deeper and is going to determine whether a observed pattern holds for a larger group of data. In very simple terms, if we have a subset of the data, are we able to, with a certain amount of confidence, make predictions around a larger set of data? This is very interesting in a lot of business applications, because if we know what the characteristics of a smaller group are, and those characteristics will lead, for instance, to sales or towards good prediction, then we can extrapolate that and use that on other aspects as well. This extrapolation holds a lot in digital and online marketing campaigns. And that's why inferential business objectives are fairly accurate in predicting the result and therefore typically return on investment. Inferential business objectives are used to answer questions like, can I already predict what is the effectiveness of a new product? Is it going to work or is it not? What kind of marketing campaigns will be most effective? Can we definitively say that a campaign within an online platform is better than, for instance, within a social media application? Other quick questions are things like, should we launch in a particular market? And if yes, which market has the best chance of success? The way that inferential business objectives work is that we always look at a subset of our data. And within inferential data analysis, this is known as a sample. In these samples, we typically have data around a smaller subset of our entire data set that we're interested in, and that entire data set is known as the target population. What we're trying to do in with inferential techniques is therefore to extrapolate and to say that if we have characteristics on a particular subset, that we can say something around the more general, larger kind of population. You can already start to see from this picture that this is going to be based on the validity of your sample and how well that sample represents the wider population. This has a lot to do with the field of statistics. And I've given a few webinars around some of the statistical techniques around inference before. So if you're interested in specific techniques like hypothesis testing, I strongly suggest that you will look at our YouTube channel and look at the video right there. Solving inferential business objectives is typically done with parametric techniques. And the most famous or most commonly used ones in those are hypothesis testing, confidence intervals, and regression analysis. So again, here you see how you can use specific statistical techniques to solve a particular business analysis business objective. If you know the objective up front, then it becomes easy to start to select which techniques you would eventually need. Good, that's the domain of inference, which is highly based on statistics. Let's dive again one layer deeper and start looking at how we can make predictions based on machine learning. And this is done in predictive, in order to solve predictive business objectives. And this is the topic where a lot of people are currently interested in, and whether it is possible to make specific predictions that will help a business predict what the future might hold. Any kind of predictive machine learning algorithm is trying to answer a predictive business objective. And whereas an inferential business objective quantifies relationship based on measurements of populations and primarily statistics, within predictive business objectives, we're going to be focusing around making a prediction around a single unit or person. So common examples are which type of product is going to be most sold next month? Will a particular stock go up or down next month? Can we explore which product returns we might expect and which product is going to be coming back the most? So within a predictive business objective, we're not specifically saying something around an entire population, but we're looking at very specified, very determined and predefined results right from the start. And that is what makes predictive business objectives very valuable. So obviously, they also are slightly more complex than exploratory or inferential techniques, because we're going to be leaving the domain of statistics primarily and now start to look at the domain of machine learning. So let me explain what I mean with that. Predictive data analysis questions are typically solved with predictive analysis algorithms as well as techniques. And they can be broadly classified into a number of machine learning domains. This picture by no means is a complete picture, but in order to get started with predictive data analysis, this is a fairly accurate overview of some of the major domains. Within predictive data analysis, you can typically subcategorize a solution either as a regression analysis, a classification analysis, a clustering analysis or clustering exercise, or an outlier detection analysis. And all of these four domains will provide answers towards predictive questions. Now, what you would obviously need to know as a data analyst or data scientist is which of these do I need to solve a particular individual goal. So underneath that, I have also listed some crucial techniques that you should know or master in order to know the differences between different types of algorithms. So for instance, in the classification box, you see a number of very common classifiers like KNN, naive Bayes, logistic regression, and classification trees. And if you're challenged with a classification exercise to predict a class of a particular observation, then you would need to know which of these classification algorithms is best able to solve this particular business objective. But before you can even move to that stage, you first need to know that the question that you have is predictive in nature. Same holds true for some of the other algorithms that you see on the screen right here. So algorithms within the clustering or outlier detection domain have a number of popular or commonly used algorithms that are relatively simple to use and for which there are many, many case studies available. So this is the domain what most organizations are already focusing on or have started to focus on in more detail. Now let's go even one step deeper and look at causal business objectives. With causal business objectives, we are not just interested in explaining something that might happen in the future, but we are more interested in why that is happening. With answering or trying to answer a causal business objective, we therefore want to understand in depth why one measurement will lead towards another. Note that this is fundamentally different from a predictive business objective, because in a predictive business objective, we're interested in the end result. In causal business objectives, however, we are interested in understanding and also explaining the relationship. So causal business objectives want to understand why certain things are happening. So to kind of give you some examples, if you are looking at sales data, one of the causal business objectives that you might want to ask yourself is, well, why did we sell more of a particular product last month? Can we find a definitive answer to that question? In the predictive business analysis that we've covered in the previous session or segment, we looked at just which product is going to sell best. But finding what causes a particular phenomenon has a tremendous business value, because if you know that, then you can leverage or use that to do more of that in the future. Similarly, you can use this to understand the capabilities of your products. So very commonly used within the pharmaceutical industry, you want to correctly understand why a particular medicine is working better than another. So again, if that's the case, you're looking for a causal business objective. So common rule of thumb is if you need to ask the question, not just if, but ask the question why, and in almost all cases, we're busy with understanding causal business objectives. Making predictions around data sets is already quite challenging, but then going one step deeper and understanding why those phenomena are happening makes it even more complicated. So what we're trying to do in causal analysis is try to simulate the changing of different variables and see what the impact on other factors will be. Sometimes the underlying design of the data collection allows you to do those variations automatically, but in many cases you will need more advanced causal data analysis techniques in order to find an answer to that question. I've listed some of the main techniques or algorithms that are used to find answers to causal business objectives here on the screen. And some of the most common ones are Pareto analysis, which is out of the three the most simple one to understand and start using. But for more complicated use cases and solutions, you could think about Bayesian causal discovery networks or constraint-based causal discovery. And I've listed some of the basic ideas around that on the slide. And obviously, if you're interested in that, in how this works, send me a message afterwards, and I'm happy to explain that. But for the sake of time, we cannot dive into individual algorithms in detail. But what I do want you to really take away from this webinar is how you can match specific analysis techniques towards a specific business question. So it also means that if you are asked a causal business question by your management or by the person that wants to get an answer to the question, that you should be able to relate which analysis techniques you can use in order to solve that problem. So this is the fifth and second to last complicated kind of technique. The last one is a very interesting one as well, in which is not in use at a lot of organizations on a day-to-day basis. And these are called mechanistic business objectives. A mechanistic business objective is not just interested in the underlying relationship of why something is happening, but it is also trying to see if we can design or optimize in such a way that changing one variable will lead towards a specific deterministic behavior in another. In more simple words, in mechanistic business objectives, we're trying to make a system in such a way that if we definitively change one variable, we can deterministically say that something will happen in the future. Let me give you a very simple example that I think everyone can relate to. So in fast-moving consumer goods and products, retail sales, a lot of people are always interested in the relationship between price and the amount of goods that you actually sell. So a mechanistic business objective would be a question like, if I play around with my price, can I deterministically predict how much inventory or how much product I'm going to sell next month? This is very relevant because a lot of fast-moving consumer goods work with expiry dates, and products are no longer healthy or can be used after a particular period of time. So it would be very, very interesting to know that if you could determine an optimal price point at which you will sell exactly the amount of stock that you still have in inventory, and therefore optimize your profits as well as results. A question like that is called a mechanistic business objective because you don't only need to understand why something is happening, you also need to design your system in such a way that it deterministically determines how one variable will change compared to another. So the question is not just around how it works, but how that effect operates on another variable. And that's why we call it mechanistic. The bottom of the slide, I've given two other simple examples because most people find this the most difficult to understand. So for instance, this is coming from obviously healthcare. Causal business objective would say that would showcase that if people smoke more, they have an increased risk of contracting a specific disease. The difference from a mechanistic point of view would be if somebody would smoke, they would definitely get a specific disease. So see the difference between the two, and they're quite different in terms of their objective. From a business perspective, a mechanistic approach will have a more significant value because it means that you are able to switch around variables in your organization so that you can predict what will happen in the future. Good. So that is a very brief overview for this webinar on a summary of business objectives. And one more time, I've given you an overview of all of those 6 different parts. And the reason that this is interesting is to determine which particular algorithms or statistical techniques you could solve if you know the question itself. And for that reason, I've made a bit of a cheat sheet. So I think this is a very good slide to take away from this session today that maps the specific 6 business objectives towards the most common algorithms that are used, or classes of algorithms, I should say, that are mapping towards a particular business objective. So for instance, if we take the second column and your business objective is exploratory in nature, then you should look at correlation, outlier detection, or time series analysis. If you want to answer a mechanistic business objective, you need to look at randomization trials. So I always think that this chart or this graph is very useful because it will immediately showcase you what type of algorithms to use in order to answer specific business objectives. And that's the whole purpose, obviously, of this webinar, is to make you familiar with this specific matching exercise. Great, so I hope many of you found this useful and that you learned something new around the value of business objectives and how you can relate that back towards specific algorithms. If you found this session interesting, there's obviously a whole lot more to learn around this. So some next steps that you could take is download, most notably, the Enterprise Big Data Analyst book, which explains a lot more detail around these 6 business objectives that I just mentioned. If you want to take the next steps as a person and become also a certified data analyst, you can start taking the examinations. And a lot of the business objectives that we talked about in this short webinar are covered way more extensively in the Enterprise Big Data syllabus. You see the picture here on the slide. So this is a free download that you can go through the website and look at and download in order to prepare for a certification as well as a credential. And if you want to have a more detailed understanding around how data in general can be used to solve particular business problems, then I strongly recommend you to sign up for our podcast, which is called Big Data Talks. You just Google that, you will very quickly be able to find it. Another key thing that I would like to invite all of you for in the future is the Big Data Days conference, which is going to be happening in May again of this year. It's a 2-day virtual program with speakers ranging from the US towards Australia and every country in between, in which we will have 800 participants, data scientists, data analysts who are live listening to sessions. We have 32 different speakers. Every hour we have a number of different tracks. So if you are interested in the whole domain of data science, machine learning, then I strongly recommend that you sign up for this particular conference. The good news is that it's free of charge, so I would absolutely not know why you wouldn't want to do this. It's a lot of free content and knowledge, just like this webinar, that is made available by the Big Data Framework. With that, we are at the end of our webinar, and I would now like to open up the floor to see if we have any particular questions. Good. Let me start moderating some of the questions. The first question is from Ben out of Australia. And Ben is asking, do these mappings between business objectives are already provided in tools, most notably in Python libraries? Well, let me first of all say, Ben, that is a very good question. I have to say that mapping, as far as I know, is not made at this stage. So it's not possible to kind of select a particular question and then see which type of algorithms you need. I'm quite sure that the answer to this question is not at this stage. Why I'm in doubt a little bit is because there's been a lot of discussion nowadays around generative AI and the fact that you can put in questions and find an answer. So it might be coming very soon, but at this moment, there is not a direct mapping yet between the type of business objective that you're trying to answer and the specific algorithm that you would need as a data analyst or data scientist. Good, thanks Biden for your question. And I see another question from Roman Abramam. Thank you very much. At the end of the session, will they share the presentation with us? The answer to that question is yes, absolutely. I will ask our team to send out the PowerPoint, or at least the PDF version of this PowerPoint to everyone, so that you will have this presentation as well. I will also make sure that the PowerPoint is downloadable beneath the recording that we're going to share with you. So that's a very good question. Thanks so much for that. Great. Those were the two questions that I have seen coming in. I think those are the ones that were in the chat right now, unless there's anybody else. No, those were the two main questions. So in that case, I would like to thank everyone for taking the time to join our webinar. We always are very excited around the large number of participants that sign up for this. So thank you so much for your attendance. In our next webinar, I'm going to be covering data ingestion. So we're going to go through 5 different sessions in which we will focus every time on one specific stage of the data analysis process. So obviously the next module is going to be around data ingestion. So if you're interested in that, please keep watching our calendar, and I hope to see you back in any of our upcoming sessions. Thanks so much, and I look forward to seeing you again. Bye-bye.